Alright folks, welcome here. We're going to start in a little bit on some troubleshooting of small engines. We're going to go through this lecture document here and we'll have a few discussions as we go along. You'll have this document as well for your review after you've gone through this video as well. One of the things about troubleshooting is that troubleshooting is kind of acting like a doctor. We are going to be diagnosing or searching for the symptoms that a patient might have, but on an engine. So we're going to look at some of the different systems and some of the steps that we would use in troubleshooting. Before we get started though, one of the things I want to talk about is troubleshooting an engine starts when you go to start it up with the very basics. Each time we start an engine, there are two things that I'm always going to do, and that is check for fuel and also check for oil. Engines that do not have oil don't run very long. With the friction that we know that is caused inside of an internal combustion engine, and no lubrication or no oil in that engine, with the amount of friction that is involved, the heat will cause that engine to seize rather quickly. So those are a couple things that you're going to start off with the basics every time. From there, I'm going to make sure that my air filter is clean, and those things are all taken care of. So fuel, air filter, oil, those are some very basic things that I'm going to look at every time before I start that engine. However, should you come at a point in time where you have good fuel, you have oil, and you have an air filter that's clean, but that engine still does not want to start, there's a few steps that you can take. One of the deals that I want to look at here is the 5 rules for troubleshooting engines. And those are spark, compression, accessories, carburation, and timing. And they should be done in this order. And we'll get to the reasons why. But one of the things I want to talk to you a little bit about is how do you remember that? Seems like a lot to remember. Something silly that I come up is that small children always carry teddy bears. Small children always carry teddy bears. Something simple, silly to kind of help you remind it. The SCACT, spark, compression, accessories, and carburation, and timing. So let's move on here. Let's take a look at the first system. So spark, we know that an internal combustion engine with gasoline powered fuel has to have spark in order to run. We know that it is high voltage created by the ignition system, and without that spark it doesn't function. So there's several different ways that voltage spark can be tested. Some are safer than others. One of the best ways that I found is using a spark tester. I pulled up an image of a few of them here. We've got some different styles of spark testers here. What you do is you take that lead off of the spark plug wire off of the spark plug on the engine, and you're going to hook it over the end here. You can see it looks kind of like the end of a spark plug. One that's pretty common is this one here, and I kind of like it. It's easy to see. You hook your spark plug wire on this end. Don't forget to ground it on this end so it'll clip on to a metal portion of your engine. And then you're going to see the spark jump this gap right here when you pull over that engine. So use that pull cable and pull over that engine several times to check for spark. All right. So that is the main way that we're going to check for spark. If you do not have spark, then there's a few things that we need to start looking at. If you do have spark and it still doesn't want to start, then you're going to want to keep moving on. But here's a couple of things here on this sheet, and we're just going to touch a couple of them that would be worth looking at if you do not have spark. First, check the spark plug. Make sure it's not faulty. We talked in class about spark plug gap, making sure that there's the correct gap in that spark plug. Make sure that's not fouled out. Remember, if you get too much carbon deposit buildup or unburnt fuel going through that spark plug, you can actually foul out that tip of that spark plug right in here. Next is checking that the armature air gap is set correctly. If you scroll down here, remember the armature air gap goes between that flywheel and our armature. So let's take a look at an image of that. So here you'll see, once again, we have our flywheel, right? And then here's our armature coil. And there should be a gap, as you can see right there. There should be a gap in that, between those two items. If this gap is not the correct gap, you can cause problems and not be getting sufficient ignition or electricity to your spark plug. We adjust this or check it via a feeler gauge. Feeler gauges are flat strips of metal at certain thicknesses to determine the clearance between them. Some of them might be, in this situation, 0.2 to 0.4 millimeters. Each engine will have its own specifications according to the manual. So, and then the last one I want to talk briefly about is the flywheel key. Flywheel keys are easy to lose, but they're also easily sheared in certain engine applications. Now, this diagram here of 6.1 shows some of our engine components in the flywheel and the flywheel key. You'll notice here that this is showing a partially sheared flywheel key. It kind of looks like a Z shape here, and that is not a good thing, because if you look here, here's our Briggs & Stratton magnetron style key. That's what it should look like when it's fresh and new. But as over time that engine starts to wear on that key, this is a partially sheared flywheel key that should be replaced. Should that key can be completely sheared, you could have issues, and that key, that flywheel, will spin freely on that crankshaft, not giving you the correct voltage that's going to spin around. Remember that as this spins around, this is when it comes through that armature. There's magnets in the flywheel and magnets in an armature. And the electromagnetic force is what gives us the spark and the generation of electricity. All right, let's move on to our next area here. Compression. We know that we need compression in our engines. Small engines have typically, 6-to-1 compression ratio. And one of the things that we're going to do is that we're going to check for compression by popping out the spark plug and inserting a compression gauge. Now once you do that, you're going to pull the engine over 2 to 3 times, and it'll read what the PSI, pounds per square inch, of compression you have. Now let's go over here and see. Looks like I don't have one pulled up briefly, but let's go in here and let's search up compression gauge. As you can see here, there's different styles, but a basic compression gauge here. This fitting here will actually thread right in where the spark plug was, and then here you have your gauge. So on a standard engine, they're showing you that here in the red is if you don't have 90 plus pounds, and that's going to be more typical for an actual vehicle engine. What we're looking at typically on small engines is somewhere 80 plus pounds per square inch. Alright, so that is a compression gauge to check compression in our small engines. One of the reasons that you might have insufficient compression is that the spark plug might not have been in tightly. You could have a blown head gasket, or you could have piston rings that are beginning to fail. Multiple different reasons of why you could have poor compression. But it is a quick, easy thing that you can do to troubleshoot your engine, is go ahead and check that compression. So let's move on down here. Rule number 3 we're looking at here is accessories. And one of those things is checking all those different little accessories. If you have a engine that has electric start, you have additional accessories that may not be functioning correctly. Also, if you have a lawnmower, let's take for example a riding lawnmower. A lot of times those have blade engagement sensors, meaning that if you have the blade engaged, it will not allow you to start the engine. The blade must be off before you start the engine. So those are things that you want to check before you jump to the next couple of items. Number 4, carburation. We know that the carburetor is where we mix our fuel-air mixture, and these can be very complex, but there's a few steps in here for adjusting your carburetor. One of the first things it talks about here is making sure that there is fuel in the engine. Now, we talked a little bit about this, that's one of those basic things and troubleshooting ideas that I always do before I get to this point. So by this point, I should know if my engine has good fuel in it. Next, you want to look for water. Water can be a really big problem in carburetors. A lot of times carburetors can be taken apart carefully, cleaned out, blown out, put the new seals and gaskets in, put back together, and oftentimes they will run much, much better. There's some steps here you can read through of how to actually set the carburetors. I'm going to leave that to you to read through, and we're going to move on here to our last step of rule number 5, timing. As we've found in our teardown of our engines in class, checking and resetting the timing is time consuming. If you think about it, we've had to tear down 95% of our engine to get to the spot where we can actually get in and see our timing. So you're going to have to drain the oil, drain all the fluids, take out your head, your cylinder head, release all of your valve springs to get in there and check on that cam gear. But it is really important that you remember this when you're reassembling your engine, because it takes so much time to get back to that point. Remember that there's marks on your cam gear. We'll switch over here and take a look at those cam marks real quick. Okay. Just like in our engines that we were tearing down, you can see this mark here. The timing gear, the gear on the crankshaft should run right into this notch right here. Not this one, not this one, but exactly that one. One tooth off can cause you serious problems. Alright, so that is checking the timing to ensure that everything is timed up right. Valves are opening and closing at the right times, therefore ensuring that you have good air-fuel mixture there when the spark plug is firing. All those things make a big difference. One of the last things here I wanted to talk to you about is the on-off switches. I know it sounds silly, but for a long time I didn't know, what do these on-off switches mean? They can be complicated, and what I mean by that, and maybe some of you will agree with me, they have an I and an O, a lot of switches. Well, what does I mean? What does O mean? O could mean on, or it could mean off. So which one is it? So I want here to dispel any rumors that you might have about what I is and what O is. O is the word or the symbol for off, meaning 0, or it's more or less a 0 in this situation. And it comes from binary or computer language, right? That coding. And 0 means off. So for all those years, if you looked at it and went, well, could be on, could be off, the 0 or the O is without a doubt for off. So if you want to run your engine, you're going to depress it to the I or the 1, meaning on. All right. Hopefully this was helpful. Remember, in troubleshooting, keep it simple, stupid, the KISS theory. Don't overthink it. Do the simple things first. Check everything out. And until next time, talk to you later.